Hi, this is Prof. Redder. I'm going to talk to you today about the iterator pattern, and I'm going to create a simple iterator pattern application demonstration. This is for my students in the Designs Patterns course at Ohio Northern University in the fall of 2016-17. The purpose for this one is to just give you a handle on what the iterator pattern is about. We're using a very simple aggregate. We're using a very simple iterator, and we're doing it almost to the point where it looks like it doesn't really even need to be done. Why can't we just use a for loop? What we're doing is showing how the for loop is designed to work, and how other loops will work as well. Keep in mind that this intent of the iterator pattern is to provide a way to access the elements of an aggregate object. And with that in mind, we need to create an aggregate object model. So we're going to do that with this class aggregate, and then we're going to create a specific implementation of it with a concrete aggregate. And then we want to be able to access the elements sequentially. And that means that we want to be able to just say, here's the first one, here's the second one, here's the third one. But we don't necessarily mean that we're going through the structure that they're, although I will be in this particular app. This app is going to use an array as the aggregate, or actually a .NET framework list. But that doesn't mean that we can't do it with some other things that aren't even linear. For example, we could iterate through a tree. If you want to look at that, you might want to go look at something called a tree traversal. Pre-order, post-order, in order, and there are other kinds of traversals for other kinds of trees. But a traversal, or moving through sequentially, is the whole concept. And this is the big part right here. We don't have to worry about the underlying representation of that structure when we're iterating through it, but we do have to worry about it when we're in the iterator. When we're in the client, we just let the iterator take care of knowing that structure. When we're in the iterator, we need to know about the structure of the underlying aggregate. So that's what the complexity is involved with this. This is the UML diagram for the entire pattern. This is right on the money with what the Gang of Four book talks about. So with that in mind, I've created an app already that's empty. I've got a client. This will become the client, but it's not really there yet, other than that it's just a blank. In fact, if I run this thing, I just get this blank window, and that's it. So we've got a lot of work to do. So the first thing that I want to do is to implement those things that are easily implementable, and I'm going to move on from there. If you look at this, the aggregate class requires that you know something about the iterator class, at least that its name exists. And so I'm not going to start with it. This is the same. And this needs to know about the concrete aggregate, or the abstract aggregate class, so I don't want to do it first. This needs to know about this. The client needs to know about both of them. And so the iterator, it doesn't need to know about anything. And as a result, I'm going to start with the iterator, and we'll move on from there. So with that in mind, let's take a look at this code, or this app, and I'm going to add a class to this app. And this class is going to be for the purpose of implementing the iterator abstract class. And it's abstract because I don't actually want to create any of these. I just want to use this as a parent. Now, if you recall, I've got over here 4 methods to create. First returns an object, next returns an object, is done returns a Boolean, and current item returns an object. And so let's go back over here and create that structure. And I'm going to say public abstract object first, public abstract object next, public abstract bool is done. And I could probably try to spell next a little better than that. And public abstract object current item. Object is the class object that's defined in the .NET framework. It's the root of all of the hierarchy of all classes. So that's what we'll use here. And we'll use something else, implied something else here in a bit. But there's my my simple iterator class, my iterator class. And when you're writing, you don't have to call it iterator. You might call it people iterator or whatever kind of thing iterator. And what you need to do is to put some indicator here to tell me when I'm looking at your code that this is the iterator class, meaning it's the class that is defined in the diagram as the iterator. Okay, so I can look at that and I know now this is what you intend to be the iterator class. So I'll expect you to have that in your submissions. So now what I want to do is to come back over here. Let me scoot this over here a little bit there. I'm going to come back over here and look at what I need to do. In order to do this, I need to have created a concrete aggregate, and the iterator is going to need to know about that. So what I intend to do now is to actually just create the aggregate abstract class. Notice it only has a concrete iterator method that returns iterator. So I'm going to create a new class by adding a class. I'm going to call this aggregate, and aggregate is going to be an abstract class, and it actually is going to define the kind of things that are in this. So this is going to be an aggregate that's specific to a kind of structure. Public abstract class aggregate, and then I'm going to put, oops, public, I'm going to put a comment out here to say that this is the aggregate class, so that, again, so I can look at your code and tell which one you intend to be playing the role of this part of the UML diagram. In here, I'm going to define the kind of elements that I'm going to be having, or the kind of aggregate I'm going to have. And in particular, I'm going to say public list of int elements. Now, a lot of books, a lot of tutorials, this is as far as they go, and give you a list of things that you're going to iterate through, and you could have done the whole thing without the iterator class. I mean, because it's already buried away in the for I equal 1 to 10 kind of a loop. But the point here is that we already understand this, but not in the context of the iterator pattern. And so we're going to do it with an array, essentially, a list of integers. I'm just using list because it's a little bit easier to mess with. And later then, we can create another kind of aggregate that maybe says stack here, or queue here, or tree here, where we've actually got something more complex that really doesn't lend itself well to doing a sequential iteration through the elements of the object. And if that's the case, then we can model that after this. So that's the purpose of this application, is to show you how to do the iterator in a context that you're already familiar with. But if you look over here, it says that we need to have a method here called createIterator that returns an iterator. That's why we did iterator first. So I've got a public abstract method, returns an iterator, and its name is createIterator. And that's all we've got. That's finished. That's the abstract aggregate class. I'm going to just save that so I don't lose anything. And now what I want to do is to create a concrete aggregate, because I'm going to need the concrete aggregate when I create the iterator. I'm going to need the concrete aggregate object to send to the iterator, so that the concrete iterator knows what to iterate through. And you'll see what that means in a second, or in a few minutes. So what I need to do now is to create a concrete aggregate class, and I'm going to do that just like I've done the others, and I'm going to do that by creating a class that derives from aggregate. And so if I look at this, I'm going to right click this, add class, concrete aggregate. Click on add, make this public but not abstract, because I want to actually create some concrete aggregates. That's why they use the word concrete, because it's something that actually exists. But this thing is going to derive from aggregate. And you'll notice I get this little blue box here that gives me this little assistant window, and I can click on Implement Abstract Class Aggregate, and it creates this Create Iterator method for me, and it returns an iterator object as the public class said, or the abstract class said. I've got to have one of these guys. So in here, I'm going to do something to create an iterator. And what am I going to do? I'm going to call the new concrete iterator. So I'm really going to need to have this concrete iterator method in order to implement that. But I really needed the aggregate completed. And I guess I could have done it either way, but I've got this. So this is fine with me. I'm going to come back here and take care of this. I'm also going to label this as, this is the concrete aggregate class. Again, for the same reasons as before. So now I've got an iterator class, an aggregate class, a concrete aggregate class, and what I'm going to do now is to create the concrete iterator class. Whoops. Doing the same kind of thing I've done before. Since it's public, it's not abstract. I mean, sorry, since it's concrete, it's not abstract. But I am going to derive from the iterator class, and I'm going to let it tell me how this is supposed to look. So now I've got this concrete iterator. But in the concrete iterator, I need to be able to create, as you see here, I need to call the concrete iterator constructor. So I have to have a constructor, and it has to have an argument of type aggregate. So I'm going to put that in the concrete iterator class in front of all of this stuff. Oops. Concrete aggregate of, and as you see here, it needs to have, I'm sorry, new concrete iterator, my bad. And in here it has to have an aggregate. And I'll just call it that. So what I need to do then is to, in this simple iterator, I'm going to need to have an aggregate object that I can save this in. Because when I create this concrete iterator, I send this. If I don't do anything with it, it's just gone. And so what I'm going to do here is I'm going to put in here this aggregate. Whoops, let me put it down here. Aggregate object called aggregate. And then I'm going to save this value in that aggregate object. That means that all of these guys down here will have access to this aggregate that we sent through the constructor call from the concrete aggregate, I'm sorry, from the concrete, that we sent like this. But we still have to do this now because concrete iterator didn't exist before. So what we want to do is we want to do that return new concrete iterator of this right here. And so the concrete aggregate object has the ability to create an iterator that knows how to iterate through it. So it's a little bit deep here, but let's return to all of this discussion quickly. Here we've got the iterator is just this abstract class that you see right here. There's nothing more to it. It doesn't rely on anything. It just stands there all by itself. The aggregate class is just this. It sets it up so that there can be a place to store elements, but the kind and structure of elements is known. It's going to be a list, and it's going to contain integers. There's also a create iterator requirement for this abstract aggregate class that it has to have a method when you derive from it. The derived class has to have a method called create iterator that returns an iterator. Now, if we go look at the concrete aggregate class, you'll see that we've simply implemented this just as you see. The concrete aggregate class has to know about how to call the create iterator for some specific kind of aggregate. And the kind of aggregate it wants is this. So we're going to create a concrete iterator for this aggregate object when we create one of these guys. And well, we'll create one of these and then we can create the iterator by calling that. Then we look at the concrete iterator. It's the thing that gets the ag, stores it in the aggregate, and now we have to implement these guys right here. So to do that, let's take a look at something here that might help you. This is just a little Word document that describes what we're going to have. We're going to have an array. It's going to have some values in it. We don't know how many, but it's going to be essentially an array. It's actually going to be, as you recall, it's actually going to be a list of ints. You may want to go to the .NET Framework documents and read about lists, but I'm not using it very fancy. And the list is essentially an array. Ours is going to have those 4 values in it, meaning that at index 0 is the 7, at index 1 is 12, at index 2 is 32, at index 3 is 2, and beyond that, index 4 and higher, the values are undefined. Indexes lower than 0 are undefined. And as a result, we want to make sure that we stay within that. To iterate through it, we want to start here. We want to then go here, then go here, then go here, recognize we're done, and quit, or at least provide a mechanism for quitting. If you recall, it's the Alice in Wonderland thing. Start at the beginning, go on until you get to the end, and then stop. That's what we need to do. So, we've got the iterator class, the aggregate, we've got the concrete aggregate class, concrete iterator, but the concrete iterator leaves something to be desired. In particular, we need to be able to keep track of where we are. And so within the iterator, privately, no one else needs to know about this. We're going to store the current index. But we're not going to give it a value up here. We're going to give it a value when we know it. All right. We're going to start with first, and first is going to simply set current index to 0. Now that can be dangerous because there isn't a if there's nothing in the array, then the current index equals 0 gives you a pointer to an undefined value. So we need to keep that in mind. But whatever we need to do, we really like to return the aggregate at a specific spot. But if you look up here at aggregate, we created this list of elements. This is where the actual data is stored. So in here, we'd like to return aggregate dot elements of current index. But it turns out that it's a little bit more complex than that. And the reason it's complex is because sometimes this makes sense and sometimes it doesn't. For example, again, if first takes us to 0 and there are no elements in the list, it's going to crash right here. So we want not to do that there, but rather down here in current item, where we can encapsulate all of the business of retrieving the current value. So no matter what, we want to retrieve this current value, but we want to do it in such a way that we don't crash when we ask for it. In other words, if there's nothing in there and we get to first and it tries to return this value, it's just going to say, man, there isn't anything there, and I don't know what to do. So we're going to say if is done, this guy right here, which isn't implemented yet, we're just going to say return null. Otherwise, we're going to return this value. And since this is a return, it's never going to get here. If it gets to here, it'll never get here. So we don't need an else on that if. So as you see, this is going to always return the current item if it exists, and it's going to return null otherwise. Our client can deal with that if necessary. So this simplifies everything else up above, because now we can simply say return current item. When we get to next, instead of that, of course, we're going to say if not is done. In other words, if we're not done, then we want to go to the next item. So we'll just move up to the next item. And then we're going to return the current item. So we just move to the next one and return it if there was one. And if there isn't one, we simply return current item. And that means that it's going to return null, because is done is going to be true if there isn't. And then is done. This may be a little tricky, but we're going to return true if current index is greater than the number of things in here minus 1. And we're going to return false if that's not the case. So here we've got what looks to be a pretty good look at what an iterator should be about. It feels right, and I believe it to be right, unless I've typed something incorrectly. But we still don't have an application. Let me save all this stuff again. We don't have an application that uses any of this. At this point, we could do something called unit testing, which you'll talk about in later courses, probably in software engineering, and we may do some of that this year, or this term. But we're not going to do it today. What we are going to do is we're going to come over here to this form, and we're going to set the form up so that we can use the current or the iterator and the aggregate that we've got. So let's go take a look at the form itself. I've created a form here that has an iterate button named m_button iterate, as you can see right there, and a list box called m_lb collection. And the idea is that when I run this, I should be able to click on this iterate button, and it will iterate through according to whatever the iterator does through this collection. So looking at the code, I've already got it done here. I've created an aggregate object from the concrete aggregate class. I've created an iterator pointer, but haven't established it yet. And then this is initialized component is part of what the form does. I mean, that's part of what is there when you create the form. And then I've got prepare aggregate with iterator. And so I'm going to use these two variables right here to collect that information. Here I'm adding a 7, 12, 32, and 2 to implement this list. And then I create the iterator by saying iterator equals ag.create iterator. And so I've got this done. So what I want to do is to cause it to iterate through these values that are in this list when I click the button. So I need to have a handler for the button click. And here it is. And what I want to do is to start at the first, keeping in mind that iterator is defined as a variable within the class. So I'm going to start at the very front end of the list, and I'm going to say while not iterator.isDone, I want to go through the list. So here's what I want to do. I want to do collection dot items dot add, and this, well, shoot. Oh, I'm sorry. This is m_ list box collection dot items dot add. And what I want to do is to add to that list box the value of the current item that the iterator is on. And if we go back and look at iterator, current item gives us exactly that thing, gives us the value that's the current iterator is on in that aggregate. And then what I want to do is, after I've gotten that value, I want to say iterator.next, and I should be done. So now that we see this, let me try to run this. And I got a problem. The problem being that nowhere did I actually create this aggregate object or these elements. All right. So notice ag elements is null. So we need to go find out where that happened. Concrete aggregates. Well, aggregate. There it is right there. There's the elements object, but I never created the elements object. I've just got a pointer sitting there. So in here I need to create a constructor, public concrete aggregate, so that when this thing gets built, we actually populate the elements object, or create an elements object, which is this list of integers. So now when I come back here, let me stop that. When I come back here and start this up again, when I click on that, it iterates through the things that I need. So that's the end of this almost. I would like to just show you a couple of other things. We can talk about this in class on Wednesday, but I would like to show you just one more thing here. It really doesn't matter how you iterate through this thing. I mean, I could choose a different way to use the iterator, and that's what I'm going to do right here. I'm going to say for iterator.first, semicolon, not done, and then the way I'm going to move to the next one is iterator.next, and all I'm going to do here is say m_lb collection.items.add of iterator.current item. Notice it's the same iterator. All I'm going to do is just comment these guys out right here, leaving that establishing the first value. No, actually I don't even need to do that because it's established in there. So I'm going to comment that out, and I'm going to use this as the iteration instead, using whatever the iterator does in terms of setting up the first, going to the next, and getting done. And then I start it and click on iterate, and I've got the same things. Now I want to show you just one more thing, and the one more thing is, what if I wanted to make a different iterator? And I could do that by creating a new class, pasting all this stuff. I'm just going to go change this iterator that we've got, but you could create multiple iterators and have them selected depending on what your user wants. This time I want to start at the end of the list, and so I'm going to say current index is aggregate dot elements dot count -1. I'm going to say current index. When I go to the next one, I'm going to go to the previous one in the list, but it's the next one in the iteration. And then down here, I'm going to just save that like it is, and come here and say return current index less than 0, because it started at the end, and when the current index gets to something less than 0, it means I've got no more values. And so let me stop. Save, I mean. Now if I start this and I run this thing, you'll see that iterating gives them to me in a reverse order. So just to go back, I don't know that I actually drug this into the view where you can see it when I ran this before. So let me change all those things back to where they were and just try to convince you that this actually did work. Start. Let me drag this in. I don't know if I did that before. And click on iterate, and you can see that they come in the other order, the order that's specified here. And when I did it the other way, with the negative, it was 2, 32, 12, and 7. As you can see here, 2, 32, 12, 7. So with that in mind, all of those things are done. That should be a pretty good introduction to you for what the iterator pattern is. Probably what I should have done in class in the first place, and I apologize for that. But now you've got this. I'll put this code out on GitHub so that you can use it as an example for yourself. When you create your app, I would like you to be doing something a little different than this. I mean, using the iterator like this, but iterate through something. You can still use a list, but iterate for some other reason. Okay? So, and remember that your app has to iterate 2 different ways. Like this one app iterated in forward and back. Yours might iterate forward by 1s and backwards by 2s, or forward by whatever you put in some text box that you would create here by that many units at a time, any number of things. Okay, so that's it. Bye.